some properties that are associated with an account, like the nonce, the balance, the storage root, and the code hash. Okay. So with the nonce, okay.
Let's just wait like 2 minutes for more people to join, and then we'll have our speaker introduce himself before we kickstart. Like exactly 5:05, so that we'll keep the time. Thank you all for joining. All right, so it's 2 minutes after 5, and we'll be starting now. I'll introduce myself. My name is Eniola Messi, and I'll be moderating this particular training. So I hope we've all gotten our journals, good network, our laptops, and our phone. So I'll be introducing our speaker. Francis, you have the mic.
Hello, everyone. Good evening.
Good evening.
Good evening. Okay, so
Yeah, your voice is
Francis.
a bit low. Can you like increase a bit?
Yeah. So can you hear me now? Is it better?
Yes, it's better.
Yeah, so I'm Francis, okay, also known as Code Blooded, and I'll be taking you through this basic Ethereum basics. So I'll be sharing my screen right now, then we can start.
Thank you so much.
So can you all see my screen? Can you see my screen, please?
Yes, yes.
Yes, I can.
Okay, okay. So now we are going on Ethereum and Solidity basics. I believe you guys have a bit of an understanding about Ethereum and how it works, okay? I want this class to be an interactive class, yeah?
Sorry to cut you, please.
Sure.
Can you make your screen a full screen? I think in the chat session, people are requesting for that. Can you just do a slide share, like a share or something?
I get you.
Yeah, a slideshow, I think.
Is it better now?
Yes, it's better. Thank you.
Okay, so yes, under the Ethereum basic, you are going to be looking at accounts and transactions. okay, gas fees, and the Ethereum structure, and also before we move to the Solidity fundamentals, okay, I would like this to be an interactive class, so feel free to ask me questions whenever you don't understand anything, okay? And also, you can contribute in any way possible. So now, going to the Ethereum basics, we're starting with accounts and transaction. Please, can anybody tell me what you understand about accounts? Sorry. I'm coming. So can anybody just share with me what you understand about an account in Ethereum or an Ethereum account and how they are being used? Okay, nobody. So an Ethereum account is an entity, okay, with an Ether balance. Transactions you're performing. Okay, so let's say, okay, is someone trying to share something?
Like, I just wanted to chip in like my own idea towards it.
Oh, okay. Feel free.
Well, just like exactly what you had in your slide, I wanted to make sure mention that there were two types of accounts, which is the externally owned account and the contract account. For like their use cases for two of them. I can't really go in depth for that.
Yeah. So you're trying to send value, or you're trying to send ETH. Yeah, you can try.
How about saying that an account is a public key that's associated with a private key?
No, it's not that. Okay. Okay. So an account or an ETH account, okay, is an entity with an Ether balance that you can use to send transactions on the Ethereum system. Okay, it does much more than that. Not only sending transactions, you can also use it to sign transactions. Okay, H2. Yeah, so as you can see, we have two types of accounts, which is an EOA and a contract account. Okay, which an EOA, okay, that is the account that have to do with a private key. Okay, so it means that it is controlled by humans. So the account you have currently on your wallet that includes your private key is an EOA account. Okay, and the one that is got, let's say, 3 contract addresses is called a contract account. Okay, so the difference is that the main difference between them is the fact that the contract account does not have a private key and the EOA have. Okay, so with the EOA mainly you use it to send value. Okay, so if you want to send, if you have like 10 ETH and you want to send 1 ETH to someone, okay, it is made possible by the use of your private key. Your private key is used to sign those transactions that, okay, fine, this is you authorizing this transaction and you are having the amount that, or you have more than the amount you are trying to send. Okay, if the transaction goes through and there's any issue with the private key, like there's a mistake coming from it, it won't succeed, it will fail. Okay, so someone else that have your private key automatically have your account. Okay, so the values, okay, like your, when I say values, okay, for you to, and also any other coins you have on your account, okay, those values are being stored specifically on that account. And anyone that have access to the private key, okay, can take everything there, leaving you with nothing. Okay, so that's why it's very important that you keep your private keys, safe. Okay, it controls everything about your EOA account. As for the contract account, it doesn't have any balance. It doesn't have any balance, and also it is controlled by code. When you initiate that, then you look into the account itself, okay, all you found is code, no value and nothing. Okay, the code execution is triggered by transaction or messages. So that code that is found in the contract account is triggered when an EOA interacts with it. Means when someone like me interacts with a contract that is deployed, okay, with a contract account, it triggers the transaction and messages are being sent and received from the contract. Okay. Hope I'm not confusing anybody.
Yeah, I just have a question. Like, for EOA, you said he has an ether balance, and for contract account, you also wrote like he has an ether balance, but you said like for contract accounts, it doesn't have an ether balance. So there's a typo there.
Oh, sorry. Yes, it will be for the contract account. It will be worked on. Sorry, I'll work on the slide. Okay, so yes, that is it. Also, thank you for pointing that out. Okay, that is very interesting. Once will be triggered. Okay, so let's continue. When you look at an account state, okay, there are some properties that are associated with an account, like the nonce, the balance, the storage root, and the code hash. Okay. So with the nonce, okay, it keeps track of whatever transactions you're performing. Okay, so let's say you're trying to send value, or you're trying to send ETH to, let's say, 3 contract addresses. Okay, for you to initiate that, the nonce will be triggered, okay, and it will mark each transactions, okay, making it 1, 2, 3. And each transaction have to go in order in which it was being initiated. Okay, that is to make sure that there is no issue when it comes to execution of this contract, because if it's not done, there's something we call the replay attack. The replay attack means that a transaction that have been done before and signed can be used again. Okay, and that replay attack is being prevented by the use of this nonce. Okay, and the balance shows the amount inside the account. The storage root. The storage root is used to show. Okay, there's something called a storage tree in an Ethereum structure. Okay, there's something called storage tree, and the storage root is showing at the linkage between this account and the storage tree. So why the code hash contains the code. Are you getting me? So do you guys get what I'm saying now? So let's look at thank you. We're looking at the next slide.
Sorry, Francis, I will ask a question. So, like in regards to the nonce, you would mention of like the replay attack. So, like is an example of this like when like you have like backlogs of transactions, assuming you want to customize your gas fees so that they can be much lower, and like they end up piling, and like your transactions are not able to go through because it's failing. Like it's failing because like you've not cleared those previous transactions, which have like the nonce that comes before, like the ones they are trying to execute after. Is that what you call a replay attack? Because of the failure for them to go through because you've not cleared the backlog.
Yes. It's trying to prevent a replay attack there, because if the first one does not go through and the third one go through, the probability that the third one will go through again is high. Are you getting me?
Okay, thank you so much.
Yes, please. Welcome. So this is a pictorial form of the contract the account. Okay, so we have the contract account which contains code by your rights, and we have the externally owned account EOA which contains the private key. Okay, so looking at it, both have the nonce, the balance, the code hash, and the storage route. So one or three keynotes to take here is that the EOAs and contract accounts, okay, they are indistinguishable by looking at their addresses. So looking at both of them address, you cannot differentiate which one is a contract account or which one is an EOA. Okay, both look similar. Okay. So contract accounts are the only type of account with associated bytecode. I've said it before. When you look at contract account, the only thing you find there is code. Okay, and private keys are generated only for EOAs. Okay, while contract accounts are controlled by the contract. So that is it about accounts. I need you to ask more questions, please, in case you have any issue.
Okay, I have a question, Francis. Good evening.
Yeah, good evening.
All right. Initially, you said contract accounts that they don't have a balance, and not long ago you said that both contract accounts and EOAs they have balances. So I actually want to be sure.
I'm looking at this. I'm telling you about the structure here. Okay, so like now looking at the images, you see both of them have code hash. But if you look at the EOA code hash, okay, if you look at it on using the tool we use, okay, when you are checking accounts, you see that this EOA accounts have no code in their code hash. Why contract accounts have code there? Are you getting me?
Okay, but I'm not talking about the code hash. I'm actually talking about the balanced stuff.
Yeah, no, I'm getting somewhere. Sure, you get. So with that now, if you also look at the balance, okay, the EOA has value in the balance. Okay, why the contract account does not? Are you getting me?
Please, Francis, before you proceed, can you make this material available for us?
After the lecture, you will get it. I will need to edit something.
Sure, it will be made available after the lecture. So let's just focus and let's type it. But then it will be sent to the Discord channel after the lecture.
Okay, so I think we can proceed. Okay, next we look at the transactions. Okay, so transactions in Ethereum is a signed data message that is sent from one Ethereum account to another. Okay, it contains the sender and the receiver information. Okay, so basically, when you are making a transaction on Ethereum, okay, there's some basic information that is present in that transaction. Okay, and looking at the structure here, you see these are the basic information that are present: the nonce, the gas price, gas limit, the receiver, the value, data. Okay, the data contains the to address and the form address. Okay, and also more details about the transaction. Are you getting me? So to better understand these transactions, okay, you can look at, if you go to Etherscan, okay, you can take a particular account and look at the transaction. We'll be doing that later during the course of this presentation. We'll look at an account, you see the You see whatever information is inside there, okay? And you will get to appreciate this more. So also looking at account and transaction, this is a pictorial representation of an account transaction, okay? So now the EOA is trying to interact with this contract account. Okay, so with interacting with this contract account, I told you that for accounts, you don't only use it to send value, you can also use it to sign transactions. Okay, so like if you have, let's say if you want to interact with Uniswap or any protocol on the Ethereum blockchain, okay, once you click on the button to swap whatever token you want to swap, they will ask you to sign the transaction. You see a pop-up from your MetaMask asks you to sign a transaction. Are you getting me? That is a way of verifying that you are the one that is actually initiating that transaction. Okay, that is what is going on here. Okay, and also with signing the transaction, it will estimate the amount of gas needed for the transaction to go through. Okay, if you have the balance, it will go through successfully. If you have insufficient fund, it will terminate. Okay, and whatever balance is remaining will be refunded to you. Okay, do you get me?
Can you come back again on the refund aspect?
Yes, the refund aspect happens when, okay, you have a series of transactions you are performing, okay, on a contract account, okay, like a protocol. You are very active there. Let's say a gaming protocol. Okay, while you are in the gaming protocol, you know, playing games, winning some, losing some, okay, at a point your balance will be low. Okay, when your balance is low and is not able to pay for that transaction, you just get a refund and your transaction will be rejected. Are you getting me? That is the back arrow you are seeing here, going back to the EOA account. The refund is not anything much before you are thinking maybe it's mostly in gray, okay? So that is it about transactions with contract accounts. Okay, there are different types of transactions. We have regular, which is from one account to another. We have contract deployment transactions. This happens when, okay, someone have a question.
Okay. Signing a transaction, does it require any form of gas fee or whatever?
Yes. Whatever transactions you are carrying out on ETH requires gas fee. Okay.
Even signing transactions, not sending transactions. Like you said, an account can be used for sending transactions and also for signing transactions. So both requires gas fee.
Yes, they both require gas fee.
Okay.
Yes,
Okay.
please. Who have questions, please? You can answer your questions. Does anybody have any question to ask? Okay, so here are the basic types of transactions, which is to send value, okay, from one account to another, also to deploy a contract, okay, and also to execute transactions on the contract, that is to interact with the contract. So that are the basic transactions that you can do with your accounts. So now going to gas and gas fees. As my friend asked, you can't perform any transactions on ETH or the Ethereum blockchain without paying for it. Why? Is because the EVM, okay, is storing complete in the sense that codes run on it, okay? And here is a case whereby Vitalik have thought about it, that if, let me say, a malicious person decides to want to destroy the network, they can just spin up multiple transactions that are unending. Are you getting me? They can spin up transactions that is in an infinite loop. So to checkmate that, that is why gas was introduced. So even if you want to run like 1 million transactions, so far you have the balance, it will go through. Once the balance, your gas is done, that is all. You have to leave the platform. Okay, to check those that will try to abuse it in the future. That is why gas was introduced. And also, gas, to get the total gas fee you have to pay for each transaction, you have to multiply the gas unit with the base fee plus tip. Okay, so the gas unit, okay, this refers to the minimum amount of gas you are willing to spend on a transaction. Okay, so let's say for transfer of ETH from account to another, that is just a basic transfer. Okay, the gas limit is 21,000. Okay, 21,000 gas. That is in GWEI, GWEI. Okay, so that is for transfer. Okay, when you're interacting with contracts, your gas limit depends on the functions you're calling on your smart contract. That is where gas optimization comes in. So when you're writing your code and you're writing functions, at the end of your contract before deployment, you can do a little bit of gas optimization, okay, to reduce the amount of gas necessary to call particular functions to your contract. Okay, and the base fee is the minimum amount of gas that is required to include your transaction in the blockchain at that particular time. So this base fee varies, okay, according to like the inflow of transactions. Let's say when there's a lot of transaction happening on chain, okay, you see the fee goes higher. Are you getting me? The fees go higher, and it will reflect on the total amount you have to pay. Okay, and the tips is if you want your transaction to go quickly, okay, you want it to go faster than normal, you have to include or increase the priority fee. Okay, so let me see. I would like us to try something here. Okay, so this is my account. This is a test ETH. Okay, can you all see my account here?
We can't see your account. Is it your like MetaMask?
The MetaMask. Wallet? Yeah, MetaMask wallet. Can you see it?
No, we can't.
Okay, I'm coming.
I think it's because of the browser Brave.
Yeah, let me reshare it again. So can you see it now?
Yeah, we can see it now.
Yes, we can.
Okay, so I want to try to transfer some of this Golly ETH to another of my account. Okay, so I will go to the account here and I'll copy the address. Then go to the account having the ETH. So when I click on send, I'm trying to perform a transaction. Okay, so I'll pass in my address. This is the address I'm sending the amount to. I'll just write one gets. Okay. So it's sending this. MetaMask have taken care of the gas calculations for you. Okay, they're doing it in real time. Checking how much the gas fee is. Okay, and doing the estimations for you. Okay, so looking at it, you can click on next. So in next here, okay, that is where you can modify your gas fee, okay, by clicking on this market here. So clicking on this market, you have low, normal, fast, aggressive. So, but this advanced one give you more, autonomy on your gas and how you can customize it. So looking at it now, see what we're seeing here. This is the mass-based fee. This is the gas limit, and this is the priority fee. You can decide to edit any of them depending on how fast you want your transactions to go. Okay. So I said for a normal transaction, it is 21,000. Look at it here. Where you can reduce it or you can take it higher. The priority fee is already set for you. You can also edit it too. This, and what is the formula again? So the base fee plus the tip fee together multiplied with the gas units will give you your total fee. Okay. I think that is it about the transaction. So please, you can ask your questions now about gas and okay.
Yeah. So I have a question in regards to like the tip fee. Is the tip fee associated with like MetaMask itself instead of like the Ethereum like governing council?
No, the tip fee is standard Ethereum process. Okay, MetaMask just does it automatically for you. Okay, but when you are interacting with any contract with code, you can decide to set it yourself. You get me? You can decide to customize it yourself based on how quick you want your transaction to go. Especially if you are building a bot now, like we have bots that perform arbitrage. Okay. Bots that perform arbitrary transactions on Uniswap, okay. Those bots, they have higher gas fees to be able to counter whatever transactions are there. So let's say the price between wrapped ETH on Uniswap and on Suchi, there's a small difference in price, and you want to take advantage of that. Okay, you can set your transaction fee, the priority fee, to be higher so that it takes the validator will take your transaction serious more than the rest, so it will go faster. Okay, there's a list of other transactions waiting. You have to be imputed in the line first before others, and you get yours executed. Please, who have questions to ask? I need more questions, please.
So another question I can ask is, so like wallets now, like MetaMask, obviously like they are companies on their own. So how do they factor in their own share, like of profit that they will take from like conducting like these transactions? Is it factored into the gas fee also?
As for MetaMask, their business, will I say, is not open. Okay, so like their contract is not open. You can't. It's not like it's verified that you can easily check the code and see whatever fee they're taking. Okay, that is one of the challenges with it. You get me?
Yeah.
That is why most of the time they advise that you use a code wallet. Yeah. You can talk. I'm listening.
You said a code something. A code what?
Code wallet. Code wallet is a different wallet. A hardware wallet. Yes. With that, you can customize everything. You own everything about your transactions and your wallet. So nothing is being done automatically for you. So is that all? Can we proceed? Okay, so now looking at the Ethereum structure, this is like a standard Ethereum structure being zoomed for you so you can understand how your transactions are being stored on the blockchain. Okay, so looking at this, you see the previous hash. Okay, these are hashes of the blocks before it. Okay, so this is the block header and the body. The block header contains the hash of the previous block. Okay, this one now is containing the hash of this block to maintain consistency. Okay, so the nonce, as I told you, is always present. Okay, to keep track of this block header. You also have the timestamp. Okay, the timestamp takes care of the time the block is being added to the chain. Okay, so we have uncle hash. This is the hash of the uncle nodes. Like these are, let's say, verified transactions, okay, that are not added on chain. Okay, this is mainly due to network issues. Okay, so two transactions or two blocks are being verified at the same time. One is being added on chain, the other one is not added. But the validator that validates the second one gets a little amount for the work done, okay, and it's being hashed and added to the header to keep track of it. Okay, so the beneficiary contains the information of this block. There is also, we have the logs. This logs also contains information of the transactions. Okay, all transactions performed on these blocks, on this block, is stored in these logs. Okay, when you query a block, you can see all the various transactions inside. Okay, so this is the difficulty. This is when they are using the proof of work. So the difficulty is used for miners. Then when miners want to mine a particular block, they have to perform a certain level of work. Okay, and that has been taken care of by this difficulty. This extra data stores more data about the block. Okay, this block number contains the number of this particular block. Okay, and also we have the gas limit, the gas use, mass hash, state root, transaction root, and so all these roots you are seeing here are all part of a tree. Okay, if you understand, we are taught about the Meku tree. Okay, the Meku Patricia tree that is being used by Ethereum. Okay, it's used to store, okay, hashes of previous transactions, roots, states, and also receipt, okay, of whatever has been done on the block. Okay, so if you query any block, even if, let's say you are a light node runner and you query or you run your node from Genesis node, you just run the node head, you can get details of every transaction from when Ethereum was being published to now. Okay, all those information are being stored in the block head. Okay, the block header. So you can do more research on this to understand it better. Okay, but if you have any questions, you can ask me.
If there's anything to speak on, because yeah, I know this is surface level, but like Uncle's hash, I was like more curious on this, because he said in this case now that like usually there are some transactions that we don't see. Some are, one is on chain, one is off chain. So like the Uncle hash now that is off chain, like is by the validator now that is helping carry out like this particular transaction that is happening here. If that's where, I don't know if that's correct, but that's what I got when you were explaining like Uncle hash.
No. Okay. So for the Uncle hash, okay, those are valid transactions. Okay. The only difference between the Uncle hash, why it's not added on chain, is because there are two that were being done at the same time. Okay, the one that is being added is the one that there's one what we call the longest chain rule. Okay, is a bit complicated if I want to go into that place, but you just understand that there's something called uncle hash. Okay, and it's just because of network fluctuations, and even though the validator has validated the hash, the transaction or the block, and is not added to the chain, they will still get something for their work done. Are you getting me? Yes, they'll still get something. So, sorry, who else have questions before we go to the Solidity fundamentals?
Okay, I have a question from the block header you just displayed. So while describing some of those elements, you talked about the beneficiary. So can you just come again on that? Yeah, the beneficiary. I didn't get the explanation you gave for that.
Okay. See, all these things, they are all informations that are available on the blockhead. Okay, so for the beneficiaries or the beneficiary, okay, just an information about, I'm coming, let me, okay. It's just an information about like the various transaction that is being done. Okay, if you want more information on the beneficiaries, okay, that is the recipients. Are you getting me? Are you listening? So like
yeah,
those
sure,
that partake in those transactions. Are you getting me? So all this, there are a lot of informations on the header. Okay, all these informations are like all the information that are gotten from various transactions, both the transactions of transfer from one account to another, and also that of the contracts. Okay, so it's all these things, as you see, like it's a very simple design. Okay, it's more complicated than this. Are you getting me? Okay, so like let's take the logs, for example. When you go to the logs, there are a lot more information in the logs. Are you getting me? So as I say, don't take my word for it. You can do more research on this, okay, to get detailed information about what is present in the header. Are you getting me? Can you hear me?
Yeah, loud and clear.
Yes.
Yes, we can.
Okay. Okay, thank you very much. So that is it about the Ethereum basics. So we are moving forward to the Solidity fundamentals. But before then, I don't know if you have any questions about all the things I've discussed earlier. If you have any questions and you want to. Before we move into Solidity fundamentals, do you have any questions on account, on the transactions? No questions, right? Okay, let's continue. Yeah, so now we are in. Sorry, please ask a question, please.
Okay, sorry to take you back a little. I wanted to ask question on the transaction. There was a time we were talking about the gas fee, the calculation to determine the total fee and all that. So I wanted to know for the gas fee. So someone asked a question, taking MetaMask for instance, if how to determine how much or if the money goes to them on how much they collect, and you're like this thing isn't open. So my question is, the gas fee, does the gas fee money belongs to, is it being reused in the system? Is it used to maintain the system, the transactions to keep on going on, or does the gas fee money goes to the company that owns, that serves now as the middleman between the blockchain itself and the users on performing transactions on the platform?
Okay, so
I don't know if you got my question.
Yeah, I got your question loud and clear.
Okay.
Please, can you answer? Okay, so with the gas fee, okay, whatever is gotten from the gas fee goes to the validators. Okay, the validators, they spend money running those nodes on servers, okay, 247, and they're incentivized, okay, and the reason why they're incentivized is to keep them, in the system, because the more validators you have, the more secure the blockchain is. Okay, and you can't tell people to participate as validators without getting anything in return. So the gas fee goes to them. So the gas fee is solving two problems. It's solving the issues of abusing the blockchain, and also incentivizing the validators that are currently keeping the blockchain active. Did you get me?
Okay, so these validators, are they people like individuals, or are they part of the people? Take for instance MetaMask. Are MetaMask serving as the validators, or are these separate individuals entirely?
Okay, so when they were still using the proof of work system, you've heard of something like miners, right? Bitcoin miner, Ethereum miner.
Sure.
Those are hardware machines that perform work on the chain. Okay, they help mine transactions, and they get something in return. For Bitcoin, they get Bitcoin, and for ETH, they get Ethereum in return. And now they've moved to proof of stake. Okay, the validators still perform a certain amount of work also. Okay, but not the one with not the mining per se. They validate the process is just a little bit different, but it's the same in a way. Okay, the validation is to check the transactions most times. Okay, you check the transactions, see that there's no replay transactions there, then you validate. When I say validate, you process the transactions. Okay, when you process the transactions, you get the gas fee that is associated with each transaction. Are you getting me? So these are not done by individuals, although individuals own the platform, companies own the platform. Okay, so the companies, like, they can come together and get a server, like a server room, or you call it a server farm. Okay, and run Ethereum nodes on them. Okay, Ethereum nodes or Ethereum clients, they are very heavy. Okay, and you need quite a sizable amount of server to run them. Okay, so when you run the get client on your node, you can apply to become a validator. Okay, there's a process for that. I think you need 32 ETH for that. So once you apply, you have your node running, then you can be a validator, validating contracts. Okay, just keep your system on. Obviously, not your personal system, your server. Keep them on, and you just keep working 247. So, do you understand what I just said?
Yeah, I get.
You can answer your questions. If you think you're a bit confused, you need me to clarify on something, you can ask.
Yeah, I mean, it's much clearer to me now. I was actually thinking maybe the validators are the companies, maybe take for instance MetaMask and some of those people that serves as a mediator between the platform and the blockchain and its users. So, but yeah, coming from the node perspective now, and people that come up with servers, which I know that most times they might not really be company owners like MetaMask, for instance. So I think it's much clearer.
Okay. Yes, that's it. I get where confusion is coming from. So that is it about gas fees and transactions. Please, more questions before we go into Solidity data structures and variables.
Good afternoon. Please, I have a question about the EOA and the contract account. You said the difference can be you can know the difference from the contract address. So I just want to know how exactly.
I think you cannot tell the difference from the contract address. You cannot. They are both the same.
Oh, okay. All right. Thank you for that clarification.
Welcome. Okay. Are we done? Can we go ahead?
Hello.
Yeah.
Yeah. So talking about you said something about the nodes and all. So I wanted to find out, working as a miner, which one is preferable to run the full node or to run the partial node? Of course, I know that the computing resources might be a challenge. Or from your experience, which one would you advise?
Your network is breaking. I didn't get all your questions. Please, can you say it again, please? I didn't get all your question.
Okay, I was talking about the node, about running the node, like you mentioned. Okay. Yeah. So I said, okay, which one would you advise? Would you advise that one should run the full node or to run the partial node? Of course, I know like the computing resources might be a constraint, but still, I think the full node and the partial node, at some point when running them, you will still need to have the full node at that point. But I just want to gain more insight. Like, what would you prefer to run the full node or the partial node?
Okay, so about that, although that is a bit out of the scope of this class, but for you to run a node, okay, as I said, you will need powerful servers for that, okay. So if you've purchased a server, that is a virtual server, okay, I have like 2 or 3 nodes running on a virtual server, but they are not ETH nodes, they're just new blockchain that are coming up. Well, before you run it, okay, there are specifics, like you have to go to the GitHub pages of the blockchain you want to run. They will give you the spec of the node you need to run their client. Okay, so if they say they need over 500 gig SSD space and all, okay, before you start running any clients on your server. And also, as I said, whether to go light or full, depending on what you want to do, okay? If you just want to just verify, like just read transactions or just monitor transactions on chain, you can go with the light node. But if you want to, perform transactions with the node directly, or you want to become a validator, you have to run the full node, okay? And you have the full node, they give you the power to be able to perform transaction directly on the blockchain. You can see transaction in real time, you can modify transactions and all. Do you get me?
Yeah, thanks.
Do you get what I said? Yeah, welcome. Okay, now moving to Solidity. Okay. So we have various types in Solidity, value types. Okay. So for value type, they are like the main, they are just like the main types, more like they are the basic types in Solidity. Okay, so for Solidity, before you can start writing Solidity, you have to be aware of their various types. Okay, the basic, which is the value types. Also, we have reference type, and we have, that is it one. We also have different variables that are available for you to use. Okay, for the value types, they are listed here, which is the signed integers. Okay, the signed integers is your int. The unsigned integers is your uint. Okay. So you have bools, you have address, you have enums, you have bytes. I believe you guys are familiar with this. Are you familiar with these data types?
Those surface level.
Not
Surface
everything.
level. Okay, when you start writing smart contracts, you use it more often. Okay. Yeah. You understand it better. Okay. Well, for the value types, they store their data on the storage slot. Okay, you allocate to it. Okay, that is, let's say, if you have uint A. Okay, I'm going to show you a smart contract, then you see what I'm talking about. But if you have like a value type on a particular slot, that data on that type is being saved on the slot, on that storage there. But for the reference, okay, the name reference means that if you check the particular slot where you have the reference type, you will not get the data saved there. You're going to get the address to the location of the data. Okay, so the data is being saved in another location and is being referenced on that slot you've given to it. It's a bit tricky. Okay, there's a formula for calculating the exact locations of those data. Okay, when you go advanced in Solidity, I think the formula will be made available to you. Okay, Okay, I don't want to end up confusing you. So, but yes, so examples of reference type, we have the arrays, we have struct, we have mappings. Okay, those are examples of reference type. And for variables, we have three types of variables. We have the global, the state, and the local variables. And the global variables are variables that already exist on the blockchain itself. Example being your block.timestamp, okay, block.number, msg.sender, msg.value. All those are your global variables, okay, that are there for you anytime. The state variables are the ones you declared yourself, okay, but this for the state variables, they are declared above the functions, okay, they are declared and they are being stored on the storage. Okay, for the local variables, when you declare it, it is being stored in the memory and it's only available during the life cycle of that function. Once the function ends, okay, that memory is being destroyed and the variables are gone. Okay, that is the main difference between the three of them. Okay, so do you have any questions on that?
So local variables. You have a question for local variables. You said they are temporary. So is it only when
Yes.
Okay. So it's just like when you're building your smart contract, that's when they exist. But by the time you execute, they are deleted from existence.
Not when you are building your smart contract. That function where you declare the memory, when that function runs, that is where they exist. After the function is done, they are being destroyed. They don't have that access to that memory. So most at times, the local variables are being tied to the state variables, in the sense that after the whole process has been completed in that function, the final result is being saved in the state variable. Are you getting me?
Okay.
Yes. Okay, so Solidity functions. Okay, this is just like a skeletal, description of a function. Okay, before you write any function in Solidity, you have to start with the word function. Okay, that function defines the functions of a Solidity. Okay, it's a keyword in Solidity. Then after the function comes with the function name. Okay, let's say if you want to write a function in Python, you start with def, def, then the function name. In Solidity, you start with function, then the function name. Okay, then after that, you declare your variables. So these variables are unsigned integers. Okay, and after declaring your variables, the next is the visibility. The visibility is very important, okay, because it indicates how your function can be called. Okay, so we have three types of visibility. We have the public, we have internal, we have external. Okay, with the public, you can call the function both internally and externally. So you can call the functions within that contract and outside the contract. Okay, if a function is external, you call the functions only outside the contract. You cannot call that function inside the contract. Then when the function is declared as internal, you can only call the function inside the contract. Take note of those three keywords, okay? Then the view. The view indicates the behavior of this function, okay? When you declare a function as a view function, okay, it means the function does not write to the state. It means it does not modify anything on the blockchain. You can only use it to view whatever changes have been made on the blockchain. So mostly we call it a getter function, okay? Then returns. Returns shows the return output, okay? When you want to return something, you have to declare it as return, and you declare the return elements, okay? So here we are returning two outputs and they are being declared in the parentheses. So this is just a simple description of a Solidity function, okay? You can add more by adding modifiers and all into these functions, but that would be dependent on you actually. So please, do you have any questions on this function before we proceed?
Can you expatiate on view again?
Views are what makes a function a getter function. Okay, when a function has view in them, okay, it doesn't modify state. Okay, it doesn't cause anything. Okay, because you're not writing to the blockchain. You're only viewing, or you're only seeing whatever change have been done on the blockchain. Okay. Do you get me?
Yeah, I'm saying.
Yeah. Oh, sorry. I have a question here. Someone is trying to ask a question. Oh, please, you can ask a question. Ask a question. Raman, your hands are up. Raman, are you here? Okay, let's proceed.
Okay, I think we can continue.
Okay, so next we'll be looking at the storage and memory. Okay, so I declared, or I said earlier that for memories, okay, they are being destroyed after a function is being run, okay, and for storage, it saves on state, okay. So that is one of the basic differences between them. Okay, so if you check, you see this stores data, okay, and the data stores can be used in between functions, okay, but memory stores data temporarily, just within that function. Okay, so data that is being stored in the storage are accessible, okay, while that being stored in memory is wiped completely. Okay, once the code is executed, that is once the function is run. Okay, to save in a storage, okay, it consumes more gas. Okay, but to save in a memory or to store data in a memory, it just consumes very less gas. Okay, and for storage, it holds array states, local variables of struct. Okay, so and for memory, it just holds that argument, function arguments. Okay, it holds function arguments for you when you're performing a function. Okay, that is the basic difference between the two. Do you understand it, or you're a bit confused?
So, like, I think it'd be much clearer if, like, it was written out. And the reason I'm saying written out is because, like, in this case, now it says memory is the keyword. So, assuming you're typing out your Solidity, like, code. So, is this something that, like, you're supposed to insert the memory keyword there, like, as part of the
Yes. When you're declaring a memory, you have to write memory there. You have to write memory. You declare it memory. Okay. When you declare it memory in the function. Okay, like you int memory, then the value. Who have a question? Somebody hands his raised.
Yeah, I have a question, and it may also lead to a suggestion. Can you hear me?
Yeah, I can hear you.
Okay, so for this particular lecture, are you going to be showing us live practical examples of all these things today, or that will be a subsequent class?
We are going to read. Okay, we're going to go through a smart contract. Okay, for you to see it. Okay, but in subsequent class, you are going to write it. Okay, or you're going to write the functions yourself, or maybe on the call. Are you getting me? But for now, due to the time constraint, I can just read a smart contract for you, so you see what I'm talking about. Okay.
Okay, that's fine, because I was about to suggest, like, all the variables and all those stuff you explained earlier, it would have been better if somebody is seeing it as you are just explaining it.
No, we are still coming. We are going to be reading smart contract. Don't worry. When we get to reading smart contract, you get to see it.
Okay. Thank you.
Okay. Yeah. So next is the contract structure. Okay. So like we have a particular format in which we write contracts. Okay, our smart contracts. Okay, you cannot just declare variables anywhere on the contract. Okay, you cannot just declare structs anywhere. No, there's a format. Okay, and looking at this image, you get to see the format. First, the variables are being declared, the state variables, the struct. If you have a constructor, you have to declare it first. If you have modifier, you have to declare it also. Are you getting me? Before you can now write your functions. Okay. Also, if you have errors, custom errors, you declare all before you write your functions. Okay. Then after writing your function, if your smart contract contains a receive or a fallback functions, those ones come later. Okay. Yes. Who have the question? You can ask a question. Somebody raised his hand. Oh. Okay. So the next on our list is on our slide is to read smart contracts. Okay, so in reading smart contracts, let's go to Etherscan. So when you verify your smart contract, okay, it's being made available for everyone to read, to access it and audit it. Okay, just go through it. So let's try to search for a smart contract we can look at. My system is working. So we are using, let's use CryptoPunk as an example. The CryptoPunk is an NFT contract. Okay. So when you search for a contract, okay, you have to check for this. There's a mark that it has. Okay, it has a blue mark or a check mark to indicate that the contract is verified. Okay, so you have to look for this mark. Okay, and going forward, you see it also have another check mark here showing that it's a verified contract. In this address, you can see a lot of the transaction that's going on. Okay, and also you can see the number of holders, the number of people that are having this NFT in their wallets. You can go through to get more information about the contract. Okay, but what we focus more on is on reading the smart contract. I think my network is lagging behind. Okay, so these are all the holders. This person is having 587 CryptoPunks. So let's go to the contract. Okay, so looking at the contract now, you see that it's verified. Okay. When the contract is verified, it has this check on it, this green check on it. Okay. So you see the code is available for you. Okay, you can go through the code. Let me expand it. So looking at the smart contract, you see the state variables are being declared. Okay, so this is how the address is being declared. I seen it, the name of the smart contract, the symbol, the decimals. Okay, it declared for this. This is a typical contract structure. After you've declared the name, contract, CryptoPunks market, you declare your variables, your mapping, then your strut. Okay, your strut, more mappings, events. Okay, before you start declaring your functions. Okay, before you start declaring your functions. So let's this contract is a lot. Just okay. You can take your time and go through it, okay, to just be familiar with how smart contracts are being written. Okay, see when this function is being declared.
Can you zoom? Can you zoom?
Can I zoom? Okay. So you see when the function first you are going to declare function, the name function keyword before the name of the function, then the variables. Okay. This function writes to the blockchain. So it doesn't have the view. I don't think there's a view function here. Okay. This contract is not having a view function. Okay. Well, there's also another contract I have here with me.
Francis, I had a question like in regards to the state variable that you're showing us for the crypto pump just now. For the state variables in that case now, like my question is like this public now in this case, like is it this public like keyword that we're seeing here? Like what is his use case here now in this scenario?
Okay, I get you. So with the public, okay, it automatically creates a getter function for each variables here. Okay, so with this public keyword, you can be able to see whatever is being assigned to this variable. Are you getting me? So let's go to this read contract now. So in reading the contract, all this thing that you have access to, the total supply, which is 10,000, you see, they're all declared publicly. Are you getting me?
Okay.
All these things that are public, you can read them. When you go to read contracts, you can read them without, without costing any gas. So you can just see the decimals, you see the total supply, you see, you can, if you read the contract and the input it needs, you give it the input here, you get whatever you need. Okay, the name of the contract, CryptoPunks. Are you getting me? Then also, if you want to write to this contract, okay, you have to connect to your MetaMask. Okay, why you have to connect to your MetaMask is for you to be able to sign the transaction. Okay, writing to a contract, I told you, is interacting with it. So as you're interacting with this contract account, you have to sign, okay, to identify you are the person that is making such interactions. Are you getting me?
Yeah.
Yeah.
So like conversely, if public was not on the state variable, nobody will be able to access it unless you are paying gas fee.
No, without public on this state variable, you will not be able to access it. Are you getting me?
Okay.
You see, like this one now, address owner. Let's see. You see that there is no address owner here.
Yeah.
Are you getting me?
Yeah.
So this address owner is not available in the read function because of the public is not there. Okay, for you to be able to access it, you have to create a getter function. Okay, you have to create a function that will return this and also make it a view function. Okay, that is what I'm going to be showing you here. Okay, so now looking at this now, you see this is a view function. What is it returning? It is returning this address. Okay, whatever address is holding this value, that is any value that we have imputed in the.
Can you help us zoom into this?
Oh, sorry. Okay. Can you see it now? Is it better?
can see clear.
Okay, so in respect to your question that you asked about um, if the public is not there, right? So now, this is how it will be declared. It will be declared as a view function before you can be able to access that variable. Okay, before you can be able to access that variable that is not in the read contract, you have to create a function, a view function, okay, and return the variable in it. Okay, like this is being returned here, just like this. So view function are basically just to return whatever is being saved on the contract. Are you getting me? So if you modify this contract and you want to see whatever you've done, like you are writing a smart contract. Okay, let's use this as an example now. This moving generic here, you can't be able to access this contract because it's not a view function. You can only be able to write to it from, it's an external function. So you can be able to write to it from another contract. Okay. And for you to write to this function, is having a modifier here. I'm using this one to show you an example. It's having a modifier. As I told you, if a modifier is in your contract, you have to declare it after the constructor. But here, the constructor is not available. We are using Ownable, which is a library from OpenZeppelin. Okay, that is a different lesson on its own, libraries. Okay, but here we are using that library. Okay, the information or the modifier that is being declared on that library, we are using it here as a modifier, okay, to restrict this function to just the owner of this contract. So the owner of this contract can be able to call this function. Okay, hope I've not succeeded in confusing you. Please ask questions though before I explain things. Okay.
But the only thing I can say now is like, so now that view that you were just showing us there. So the only way, assuming there was no public now. So the only way now for someone now to be able to access it is like the person has to write to the smart contract to this view, like
yes, you have to write this view functions. Yes, this view function for it.
Okay. And that's when you now pay the gas fee because you're writing to it to be able to see it now.
No. With the view function, you will not pay gas fee. You will not pay gas fee. So far you declare it as view, you will not pay gas fee. It just means that you have access to the information in that variable. Are you getting me?
Yeah.
Yes. So this will give you access to that variable, to the information there. Without the view, you won't have access to the information. Are we clear on that?
Yeah.
Okay. Please, who have questions to ask me before I proceed? This thing can be tricky in a bit, so. Are we all clear on this? I believe more people will have questions though, because this is where most, or you guys have not done functions or smart contract structure before.
Like Francis, like I don't know, the questions are plenty. That's just the truth, but like
ask some questions, because with asking questions you get understanding.
But like the question now that I have now is I don't even like it's not related to what we are doing here, but it's still related to it. You get what I mean?
Because okay, you can ask. This is going to make us more confused than maybe you have to.
So
I get you. Okay, I just don't want to proceed without you having proper understanding, because the more you go forward, the more it becomes a bit confusing. So you have to understand the basic first. You get me? It's very important to understand the basic. So next we have is smart contract ABI. Okay, so when you compile your smart contract and deploy it, okay, it compiles into bytecode and ABI. Okay, so the bytecode is what your EVM understand. But human beings, we don't understand the bytecode. So Solidity have made ABI available to us, okay, for we to interact with from the front end. Okay, so if you are a smart contract front end developer, okay, what you'll be more concerned with is this ABI. Are you getting me? Yes. So this ABI, you'll be able to have access to all the functions that are being declared on your on your smart contract. Okay, do you get me? So looking at this, let's see whether I can get. Okay, so this is an example of the bytecode. Can you see it?
Yeah.
So you can't understand this. It won't help us. So there is a provision for. I have an API here. Okay, let's see. Deployment here. Okay, so let's look at this API. So this API is your normal typical JSON format. Okay. So this is the inputs that is taken. Okay, so all your functions are being declared here. So this is the constructor, and this is what the constructor is taking. Okay. Just so when you are interacting with your smart contract from the front end, this is what you have to, you have to study more, go in depth to understand this data structure, because you have to be able to navigate to the particular functions and the data type you need. Okay, this is a bit long. We can't be able to exhaust it. Okay, well, you can do that on your own. You can write a typical small smart contract, or you can install that. Okay, it comes with its own default contract. Try to deploy it, then you go to the contract to access the ABI and the bytecodes. Okay, that way you can understand it better. And next is events and logs. Okay, so in Solidity there is something called events. Okay, what the event does, okay, is to keep track of whatever changes is being done on chain. Okay, so if you are writing a contract, okay, and the contract is going to modify a state, okay, it is advisable you declare an event, okay, to log that change. Okay, this will help you keep track of whatever changes is being done on the contract. Let's say you have your typical ERC20 contract, okay, and there's the transfer from function. Okay, you need to have an event that will capture that transfer from functions, okay, and the transfer, the to address and the from address, to know what you are transferring and to whom you are transferring. Okay, here is an example of how the logs look like. Okay, it contains a lot of information you will need, okay, when you are deploying your smart contract and you want to interact with it. Okay, so this log is very useful, especially when you are testing smart contracts. Okay, because if you've transferred, let's use it using the ERC20, if you've declared an ERC20 token and you've transferred some of the token to another address, okay, you need the event log, okay, to test and see if the transaction was successful, okay, and if the amount you transferred is the exact amount that the receiver got, okay, all we captured in the event log. Okay, we also use it to You can also index variables, okay, to be able to, rebuild the storage state. Okay, when I say rebuild this, to be able to quickly call it from that state, okay, from that storage state. If you want to like revert a function on the contract, you need to index, okay, the variable. You need to index the variable to make it will just give it a special form, okay, in the sense that it will make it one easily available for you in the logs, okay, because index variables are a bit separate from the normal variables on the logs, and also it's easier for you to work with it when you are rebuilding your storage state. Okay, and also it listens for changes, as I told you, in the front end. So let's say you are interacting with a contract that have to do with like a game, okay, a smart contract game, okay, and you won the game or you lost the game. To keep track of your winnings and your loss, the event is being called upon. Okay, so it's the event that is being checked to see, oh, you've won, this is the amount you won, and to be displayed for you on the front end. Okay, you can also use it to create a subgraph. Okay, as I said, subgraphs is just an indexed form of this data structure, in the sense that it will make the data available for you easily. Okay, because for this event, okay, a lot of events happen on the smart contract quickly. So it's very difficult to keep track of it. But when you mark an event as index, okay, it's easier for you to call the logs. It's very easy, unlike when you don't. So it's advisable to mark your events as index. Okay, so let me see if I can. So let's see. Okay, so this is an on-chain game. Okay, this is a smart contract game that has been deployed, but this is on testnet. Okay, so let's try to play a game here. So to be able to interact with this contract, first we have to connect our wallet, of which it has done so because I've connected before, so it immediately just connects automatically. Okay, and let me refresh this. Okay, so I'm switching my network. So this is an example of a smart contract interaction. Okay, let's say you want to interact with this contract. Where's my balance? My network is slow. So wait. Okay, so now let's try to play a game here. Okay, so now, okay, when you click on this bet here, okay, it pops up your MetaMask. Okay, this is going to bring out an information that you have to sign this transaction. Okay, you see it here, contract interaction, boldly written here. And you have to confirm. So when you confirm it, then okay, so the transaction has gone through. It's very fast. Let's go. Time. So this is the same way you interact with other contracts on chain. Okay, whenever you click on swap or Uniswap or any functions on the contract, it pops up your MetaMask or any of your wallets. Then you sign to confirm your transaction. So once you do that and it's confirmed, then the transaction will go through. Okay, like I've signed the contract, I've signed this transaction. Okay, so now if you just play the game for me. So watch here, this place that you are seeing the win and the losses being displayed is made possible by the events. Okay, here that is keeping track of the losses and the win is made possible by the events. Okay, and the event, it makes it faster for you to get the information, okay, from the chain, from the blockchain, and display it to the user. Are you getting me?
Yeah, so it's something that happens automatically.
Yes. I think that is all. Please, you can ask your questions as we proceed. I don't want anybody to be confused after this lecture. So last but not the least is our factory contract. Okay, for this factory contract, okay, it helps us deploy our smart contracts. Okay, like it deploys copies of our smart contract for us. Like looking at this diagram now, you've written a contract, let's say an auction contract or a bank contract that have the addresses and the amount that you are willing to save on that contract, okay, based on how you've written the code. Okay, you know, the design decision is best left to you. But after creating your bank contract, you want to create copies of that contract for different people. Okay, for different. So if somebody wants to create his own bank details, okay, instead of deploying another contract for the person entirely, you write a factory contract. The factory contract will be what we deploy another contract for you with the copy of your contract code and your state variables. Okay.
I'm kind of confused with this one.
Okay, let's see. You've written an auction contract. Okay, let's use an auction contract and as an example, or a lottery contract now, like this one.
Okay.
So this is a lottery contract here. So when you generate these lottery tickets, okay, and you buy the ticket, it creates a lottery account for you, not an account like it deploys this lottery contract for you. Okay, it deploys the lottery contract specifically for you, okay, as the owner. Okay, and that is being made possible by the factory contract. You also you can also use it. Okay.
No, okay, no, you were saying that by the time you connect like this, like a fresh account, it deploys your own factory. It
So
deploys
by the
your
time
own.
yes, your own lottery contract, okay, deploys the contract for you.
Okay.
It's used mainly, okay, when you have a contract, okay, that you want to use, or you want to use each state, repeatedly. Okay, you want to use each state repeatedly, like this lottery as an example. Auction is also an example. Okay, if you want to auction your NFT in an NFT marketplace, okay, you are going to declare your NFT and you are going to start your auction. In starting your auction, okay, this creates an auction contract for you. Okay, it creates an auction contract for you. It's not like a new contract is being created for you. It's a contract, okay, but it's having the same state variables and the same code that have been deployed already. Are you getting me?
Yeah.
So it's having a copy of the same code and state variables. It's just that the information that is in that contract is different, okay, for the different users that is interacting with it.
Okay.
Okay, like in this image now, you see that somebody created a bank and he created a bank factory. Anybody that is calling the bank factory contract will be creating different banks for himself. Are you getting me?
Yeah.
So it's not like he's deploying a new contract for you, although he's deploying a contract for you, a bank contract for you, but it's having the same code, and it's just to make there's what makes it possible, the new keyword. The new keyword available in the factory contract, like, creates an instance of the contract. Okay, it creates an instance of the contract, and that is what is being deployed.
Yeah, that is clear. That's clear.
Hope I'm not confusing you. I'm trying as much as possible to break it down, because you need to understand this, okay? Because when you are going to be writing your contract, the person that will be taking you think that maybe because you have idea on it already, you might not be able to explain it deeply for you. That's why I need you to ask a question so that we can see how far I can go about explaining this. Please, if you have questions on this factory contract, you can let me know.
Yeah, thank you very much. Sorry, my question is, why do we need factory contract in the first place? Like, what are the use cases in the real world?
Okay, one of them is for you to easily deploy contracts, okay, that are reusable. Are you getting me? Can you hear me?
Yes, I think
Yeah,
I got
so
that.
if it's something that is reusable, I use this lottery as an example now, and I've used auction. Okay, this is something that you are going to call. You are going to create. Okay, you are going to create the lottery ticket every single time you interact with this contract, with this lottery contract. So when you create the ticket or when you interact with this contract, it creates an instance of this contract for you. It creates an instance of this contract for you, whereby it have your information on it and all the ticket numbers. Okay, it might be different different ticket numbers, but it's just the same code and the same variables.
Okay.
You also,
yeah, thank you.
Also, going forward, when you are going to, maybe you are going to be writing a multi-sig contract, I think. When you are going to be writing a multi-sig contract also, you will need to write a factory contract to create different multi-sig contracts or different multi-sig accounts for your different users. Okay. So when you get to the practical aspect, that is writing smart contracts on its own, you understand the use of this factory contract better. Okay. So please, more questions if you have questions. Please, more questions if you have questions. You can ask questions from anywhere, from the beginning, from accounts to smart contract ABI, events, logs, smart contract structure.
Well, Francis, I have a question, but like in order to avoid confusion, like is it possible that I can ask you like after this lesson? So if you can give me your social media links, or if you're on the Discord, maybe if I can message you there, like because.
Okay, no problem. So that is no problem. I'll let you know. I'll give you my Discord account after the class.
Okay, thank you so much.
Welcome. Please, any other? So this is the reference. Okay, when you get the slide, you can go through these links. Okay, to read in details. Okay, some of all the information here. Okay, if you want to understand more, just click on any of the links. It will take you there and you can read about it. Okay, so please, more questions. Are we okay? Are we okay with events and logs? Are we okay with smart contract ABI? Are we okay with reading smart contracts? Please, if you are confused, I've not heard some people's voices since. Do you want to tell me that you've understood everything?
Okay, Francis, I have another question. You know, before, like when I asked the question of how events and logs, like when I asked that particular question of when it happens automatically, like it was when you were interacting with the just bet, like in DApp. But like on writing, like Solidity itself, like is it something that happens automatically there, or is something you have to do manually?
I did not get your question, please.
So you know when we're on the Just Bet platform and you were playing the games and like the logs were being recorded, like the events were being recorded, I asked the question then of, okay, so it happens automatically, but like earlier before then, like when you first made mention of like events and log, you said that it is necessary that you put it. You said that it is necessary that you put it down. So I'm asking now, like when you're writing the smart contract itself, like it doesn't even have to be like that just bet. But like when you're writing a smart contract, is this something that you have to do manually, or is something that will still be happening automatically when you are logging or doing events or registering events?
Are you asking, is it the event you're asking that you have to write manually or what?
Yeah, that's what I mean. Because in that case now of just bets, like it was happening automatically as you were like interacting.
Yes, the event is written in the smart contract itself.
Okay. So
yes, it's written there. I think. Wait, I'm coming. Let me see there. I'm coming. Sorry. Oh, okay. It's not event written here. The event is written in the smart contract itself. I'm trying to see if I can get a typical event for you. Okay. Mm. Mm. Don't worry, when you're writing smart contract, okay, you'll be shown how to declare event in your smart contract. Trying to look for one here, but I can't find it.
But that's fine though. Like it was just like that was just where the confusion came because when I asked that question, it was when you were playing the game and he said it's automatic. So then I was like, you get what?
No, you have to declare an event. Okay, when you declare an event, whatever you declared to be stored in that event will be stored in a data structure which is called logs. So we call it events and logs. The logs is the data structure. Okay, why the event is what creates the logs for you. Okay.
Yeah, that's fine.
Yeah. Please, more questions. Just to clear any doubt, if you have any doubt at all, you can ask questions. Especially with these functions, because we're writing a lot of functions in the nearest future, so you need to be able to understand what you are writing. You get me?
Yeah.
So please, more questions, okay. So
I hope everybody understands what Francis has been teaching since morning. Please, if you have any question, please ask. Please, I know for some people that are actually new to the entire Solidity and mass contracting might be sounding like German. But please just ask questions, please. Even if you are confused, just ask questions so that you can probably go over it again and you will understand better. And if you are shy to talk, you can always type your message in the chat box. It's okay. All right. Thank you, everybody. Francis, you can continue.
Okay, so I'm done basically. Just maybe I'll ask one or two questions, see they know to ask
All
questions.
right. Okay. I think that will be better. Okay. I think we are done with the class for today. So question and answer time.
Okay, so can someone just tell me the difference between storage and memory?
So I can answer that. So the difference between both of them, according to what you explained, like we said, memory is a keyword. Or like in this case now, you use that memory function like when the memory function. I mean that memory keyword that you use, its use case expires on interacting with on executing the function. But like for storage itself, like that's the main like
Yeah.
property solidity. So that one has much more, how do I put it? Like it's not
It's
temporary.
persistent. The right word is persistent. When you say a variable or a data is persistent or a storage is persistent, mostly in Web 2, when you say something is persistent, means it's being stored on the database. You understand?
Okay,
Yeah,
persistent.
but this is not, this database itself that is being stored is on chain. Okay. So when you say storage is persistent, it means it's being stored on chain. The data is being stored on chain. Okay. And it consumes more gas as against memory. Okay. Okay. I think we've come to the end of the class. I will stop sharing my screen now.
All right. Thank you so much for that, Francis, and for everyone that joined. Like Eniola mentioned, I know like this might be pretty new to all of us here, but at the same time, we'll share this recording and also the speaker slides. Once he shares it with us, we'll forward them to everyone via email and also on the channel. And then If you still have questions, the author would also be available on the channel where you can tag him for questions or clarifications over time. So it's good you take your time, try to understand on your own, like read up on some few things, and also the speaker would share, I believe we share a few resources with us if there's a need for us to follow through. I believe there's a need for us to follow through anyways. So that would help us to stick together and try to refresh our learning process and what you have learned so far before our next class, right? So thank you all for joining once again, and big shout out and big thanks to our speaker, our mentor for facilitating this wonderful and amazing session. Really appreciate your time. So somebody asked that please share some additional resources like you did the last time. Yes. So uh, our speaker also will be looking forward to get a few resources that could help people um, level up and also read more in depth about this particular stage that we are currently, considering the fact that going forward we'll be taking a step ahead, which means that they need to understand the foundation before they proceed to the next stage. Yeah, I hope to get that from you. And guys, this is recorded once again. We'll upload it and share with everyone, and also share the slide via your email and on Discord. Eniola, are you there? Passing the mic to you right now.
Ola, sorry, I have a question for you. Or Idris. I don't know if I should call you. Ola or Idris. Which one is better?
Anyone is fine.
Okay. So
Eniola, are you there? Okay, just proceed with your question. Sorry.
Yeah, so like we're doing this 44-day program now. Is there any certificate or whatsoever that comes with it? Or it's more of just experience itself?
Yeah, there would be a certificate of after the whole program, right? For those that participated and also for the active ones. And remember that we would have an hackathon after this particular. Remember that we would have an hackathon. This whole training thing, right? So that's also like this whole training thing, right? So that's also like a reward for those that participated, even though the hackathon would probably be open to the public to apply, which will give more opportunity for a lot of people to benefit from it. Yes. So, and again, I also wanted to just share with you guys, specifically our classes are on Mondays, right? We just want to keep to that time so that maybe you can clear your schedules within 5 to 7 on Mondays. But on Thursdays, we'll be having a 1 hour session. Not every Thursdays, right? But we are starting with this Thursday from one of our sponsors, the sponsor of the hackathon, and also part of the people that are helping to facilitate this whole training program, which is going to happen on Thursday, where they come and explain like things in the real world with what is happening in the Web3 ecosystem, and also helping you people that participated in the training to understand how to leverage their platform very well prior to the time that you'll be building, prior to the time that you build to participate for the hackathon, which gives you like an edge over somebody that just randomly, joined at the point of the hackathon, right? So just we'll send reminder for every event, right? And also would reach out to everyone on the Discord server to announce. It won't be every Thursday, right? But it's specifically scheduled for Thursday to invite those people. Then Mondays are strictly for our lessons, and we will not be doing anything on that day aside our classes to make sure that we are following up. Then on some selected Thursdays, would have like people from the partners to come enlighten us more and also tell us what is going on within the ecosystem that is way more beyond coding, which has to do with community, building yourself as preparing your mindset for the job market, and how you can be good out there, be ready to compete with anyone to secure a role in the Web3 space.
think that's it. I think Eniola, I hope I answered your question, right? All right, cool. So, V, I hope I answered your question, right?
Yeah, that's fine. Clear, loud and clear.
All right, cool. All right, so Eniola, are you there?
Yes, I am.
All right.
All right, yes. Okay, thank you so much, everybody, for your patience all through, because it was, I think we had a very large amount of like close to 50 people joined initially, and we are closing with around 22 people. So thank you guys for your patience, and I really hope you learned a lot. So there's this arc about learning. You have to go back and research on your own to understand better, and from there you can pick it up. So on to the next class, where I'll see everybody. The channel is available on Discord if you have any question, and I'll make sure that I send in the material that was used for the class as well. So thank you so much.